Okay, this matrix takes xyz to xy0, which effectively takes a point in three-dimensional space. So we've got an x coordinate, a y coordinate, and a z coordinate. So we can depict that like so. And then we have to come up this far. So here's a point x, y, z. Okay? And down here is the point x, y, 0. Well, every point above or below x, y, 0 is an x, y, z. Okay? And every such point maps to x, y, 0. So what we're doing is we're taking the whole three-dimensional space and projecting it down to the x-axis. We take every point, because x and y could be anything, every point in three-dimensional space projects down to the point directly below it or above it, because there are points below the xy plane, but the point in the xy plane. Okay? It's called a projection. Now projections are really important, like in three-dimensional graphics, you know, video games. You got to project everything onto the plane perpendicular to the viewer's line of sight. And that plane isn't always the x plane, the xy plane, or the yz plane, or whatever. It's some plane in space that changes as the viewer changes their perspective, right? Well, you got to use projections. And this is a simple example of a projection. Okay? It turns out this is also a projection. Okay? We're projecting every point onto the span of these two, onto that plane that I just indicated. Okay? Just a little more complicated. It's not maybe exactly a projection, but it could be a projection with, well, maybe not a perpendicular projection. And we'll deal with that later. Okay? But the idea that you have projections, that's one thing that vector transformations can do. Discussed in your book with examples, but pretty much similar to the example I used. Okay?